Okay, so this problem, we have a person going down a slide. The height of the slide is 38 meters. We want to know what the velocity is going to be of the person when they reach the very bottom of the slide. So they're going to be at a height of 0 meters. It probably won't tell you that. It'll probably just say at the bottom you have to know that it's going to be a height of 0 meters. But that's just something to know. So we're given mass. We're also given the height. And remember, he's going to be going downward, so it's going to be negative 38 meters is your height. We know acceleration. Notice it's going in the y direction, so acceleration of gravity is negative 9.81 meters per second squared. Our unknown is we're going to be looking for this velocity final at the very end. So the equation I'm going to use is the conservation of mechanical energy. And so what that means, mechanical energy at the beginning, initial, equals mechanical energy at the very end. So what I'm going to do is I'm going to expand these. So mechanical energy initial, remember mechanical energy is all your potential energy plus kinetic energy. So it'd be potential energy of gravity plus potential energy elastic plus kinetic energy. This is all initial. And it is going to equal the same thing, potential energy of gravity plus potential energy elastic plus kinetic energy, but instead it's going to be for the final. Okay? So I just expanded what mechanical energy is. It is all the energies added up together. Okay? And we have an initial and it has to equal our final. So what I'm going to do here is I'm going to ask 3 questions. Okay? The first question deals with potential energy of gravity. So the question 1 is, do we have height? Okay? So question 1 is, do we have height? Yes, at the beginning we have height, right? So we need to keep this. Number 2 is, do we stretch or compress? Well, when you go down a slide, you do not stretch or compress. It talks nothing about anything stretching or compressing. So what that means is we completely get rid of potential energy elastic at the beginning. Number 3, the kinetic energy. Okay? If he starts up here and he hasn't moved yet, does he have any velocity? So question 3 is, do you have velocity? And at the beginning, he has no velocity before he starts going down the slide. So we do not need kinetic energy for the initial. Okay, so notice we went through the 3 questions for the beginning. Now we have to do it for the same thing but the other side. Okay? So question 1, do we have height? At the very end, the final, does he have any height? No, because he's going to hit the ground, right? So we can get rid of potential energy of gravity. Does anything stretch or compress? No. Do we have velocity? Well, yeah, that's what we're solving for, right? Is velocity. So we're going to keep kinetic energy. Now that we use these 3 questions, I'm going to erase them so I can expand this. So what we're going to have is potential energy of gravity initially, so this would be initial, is going to equal our kinetic energy final. And so I'm going to expand because potential energy of gravity is equal to mass times gravity times height. Remember, this is your initial. And it's going to equal kinetic energy, which is equal to 1/2 mv squared. And this is going to be your final. So I'm going to use these 2 equations, or these 2, to solve for his final velocity. So what I'm going to do is just rearrange the equation. So I'll have mass times gravity times height. Going to divide by 1/2 m. And then I'm going to take the square root to get velocity by itself. If you notice, your mass is in the numerator and the denominator. You can actually cancel them out. You don't have to. You can plug them in, but I usually just cancel them out. So you would take gravity, which is negative 9.81 meters per second squared, times your height, which was negative 38 meters. You're going to divide it by 1/2, and that will get you your velocity. Don't forget to square root. A lot of people do that. Don't forget. You're going to get a velocity of 27.3 meters per second.